Welcome to a new tutorial. I'm Alex, and if you're new here, make sure you subscribe. Today we are going to learn a couple of new things, as well as we are going to do some fascinating projects. All the projects we did so far are based on LED. This is based on LED, but it will be something interactive. So what exactly is the project? The project is that we are going to use the sensor that is present on the Mbed board, and using that sensor we will try to vary the intensity of the LED. In our last tutorial we saw that we could vary the intensity of the LED using the pulse width modulation API. We will use that API. This time we will take the input from the user, that is the one with the Mbed board. So before I go ahead into the lesson, I will show you where exactly is the sensor on the Mbed board. As you see on this image, this white piece is not a space for you to touch, because this exactly right over here between these two poles is a sensor. And when you hold your board in such a way that your SDA connector is facing downwards and your board is held towards you in this way, this area, which is the sensor, starts from 0 on this level. That is, the sensitivity is 0 from here, and as we go above, it goes from 0 to 100. Please note that this is the percentage, that is 0 to 100 percentage, and not the value. Now that you know that this is a sensor, to use a sensor we have to import a library. That is the second thing that we are going to learn, but as of now I'm not going to import the library. Let's just write the code as of now, and we will try to import the library when the error pops up after saving. Okay, the only thing I'm going to tell you for the sake of writing this code is we are going to include a new library called TSI Sensor. TSI is capital and S is capital in sensor.h. H is a header file, definitely. So for doing this project, we know that we are going to vary the intensity of the LED, and to vary the intensity we know that we need to use PWM ouch API, which we did in our last tutorial, and this is the LED which we use as object, and we will use the blue LED whose pin number is PTD1. TSI Sensor is just a library. You have the library, but you need to get the book from the library in order to get the required knowledge that you need. So we have the library, but we haven't issued a book yet. So that book would be a API here, TSI Sensor, and TSI is an object right over here, and usually we have something in brackets because that is the standard line of code what we did till now. But for sensors we need not define the pin numbers because it already knows that the place of the sensor is fixed. So do not put any brackets or anything, just define an object. Instead of TSI you can write XYZ, ABC, or your name. I'm going to go with a sensible name, TSI Sensor. I will comment so that you don't make any mistakes. Till now in all our projects we used just the LEDs, so we didn't have the requirement of using or knowing what type of communication that we are using. But now that we want the input of the user, we need to know what type of communication we are using, and that's when the concept of serial communication comes into picture. UART, you must have heard about it. UART stands for Universal Asynchronous Receiver and Transmitter. Since this is a serial transmission, it also has to be defined. The computer and the embedded board does not understand what you're trying to do, so you need to make them understand using these codes. We try to vary the intensity using the PWM. We are using the sensor using the sensor, but how do we take the input? So we need to define that with the following code. Serial PC USB TX is capital and USB RX is also capital, and then semicolon. You cannot change this standard default code method anyhow. You have to write USB TX and then you have to write USB RX. If you write USB RX first and USB TX later on, it won't work at all. We'll start the int main here. We know that we are going to take an input from a user, so we need to define a variable. We will do it as float is equal to t. Why float? Because we need to make sure the intensity is between 0 and 1, and that can be only achieved if you're using float. If you're using a whole number integer, then it's either 0 or it's either 1. The first line of code would be to take the feedback from the sensor And in order to do so, we define T is equal to TSI dot read percentage round brackets and a semicolon. This line of code will take the input from users and it will store it in T. Now we have two options. Either we can print the value on the screen, or /end we can see the output using the LED. We will try to do the both, but we won't use teraterm for looking at the values. Still, if you want to use teraterm, you will get the values perfectly. I will write the code for it, but we won't see it. Okay, so it is pc.printf and then goes in your bracket where your line of code will be there, with ends with a semicolon. In this quotation marks, if you say T is equal to %f, %f is the value of float, which is T. This T is just a sentence or a word for your understanding. You can say this is my value is equal to %f. You can't write T because T is not considered. Okay, and just to make things little sophisticated, we will use /n, which means next line, and /of, which means the first point of the cursor to the start. Instead of float, if we had used integer, then we would write %d. We know we are going to print a float value, but which float value? Because you might have 100 of float values, so this is where your variable goes in, which is t. We want to play with the LED, so definitely we are going to write LED is equal to what? It is 0 or 1 and we are varying the intensity. So as per our condition, it must be 1 minus t. So whatever value is t, the intensity will change according to the input. Then we add a delay of 0.02. If you touch the sensor, it will take 5 seconds for it to react, and that's not really feasible nor recommended in real-time operating systems, especially when you're using feedback networks. This is the code, save, and when you try to compile it, it will pop up an error because we didn't import a library. Look, right here it says no library found. So now we are going to search for this library. Copy your file name, go on to the developer.mbed.org. On the top right corner, there is a search bar. Go and paste whichever library you're trying to find. You can simply type as TSI Sensor or Sensor, it will definitely pop. And there are various libraries that you can import for this file, but a really good library that I recommend you guys is from the user Emilmon, which is under a Mercury repository. Click on it, a new tab pops up. The details will be listed down below, you can check it out. Click on import into compiler. Another new tab pops up. Wait for it to initialize. This tab will pop up. Do not change the source URL and make sure your library is checked in. No need to mess with the import name. All you need to do is select the target, that is the program that you already wrote by Alex. So this is the program that I want this library to be imported in. I click on import. These are the files that I got from this library. And on the left hand side, if I see the tree of my libraries, I can see that I have imported TSI. So I just click on the main.cpp so that I can go into my program and compile it. We have successfully imported the TSI Sensor library. All we have to do is just click on the compiler to compile it. And make sure once this new compiler tab pops up, just close the old one, or else it will show that multiple sections are detected. Now try to compile. You will get the file. Open it in the folder, copy it and paste it in the drive of the hardware. And this is the following output that you will get. You can touch the sensor wherever you want and you can see the intensity of the blue LED is changing depending on where I touch it. You can also use red and green LED by their pin numbers. So that's it for this tutorial. I'll see you in the next one. But before you leave, make sure you smash that like button. Thanks.